Hi folks, in this video we're going to see how to do a health check in a OpenShift cluster, a general health check in the terminal and the GUI also. A basic in day-to-day activities, how we will inspect the cluster, or we're having an overview over the cluster. So what are the main components and parameters we want to consider that the cluster is being in the stable or in the perfect structure? So that's a main thing. So first thing we will talk about the cluster components and what are considerable parameters that we want to consider. The first thing is a overview. Most of uh, components we can get it confirmed in the dashboard itself. Okay, let me log in once. Let me show you. So this is CRC environment. So but the similar will be in the production as well. So I'm working in the production environment, so that's why I'm just showing how it will be a similar. We could um, consider this. Okay, so in overview we can consider a lot of things. So basically in here itself we can see cluster inventory. This is the main thing we want to consider. So here, if any node down or pod down or storage issue or ODF issue, storage, anything else, we can get it conclusion here itself. So node down means here itself error will come, and any cluster like see status, entire cluster status, it's fine. And control plane components. So 4 components will be there. These are the core components. We should consider them, and everything should be in response rate. It should be 100. And operators, major, it's in a cluster's backbone like that, and the resource conceptions. So here we can see one error. So that is a alert manager receiver not configured. That means we didn't configure the alert manager. When the alarms getting fired, it should throw the uh, trigger the alarm to a particular platform like Slack, email, or Teams, like that third party platform that the user should aware about it. So such thing I didn't configure, so it will be like in the alarm, like warning state. So we can ignore this. So we can ignore and observe. So alerting silence, we can silent that also. So here we can silent the alert. Okay, okay, we can ignore this. So next, then on we can consider um, operators. Okay, these are installed operators by the, so if we require any additional feature to add in this cluster, we can add it from the OpenShift operator hub. Here everything will be available. Most of the operators will be available here. So for example, metal LLB, usually it is very important load balancer, so it will be available. In CRC also it will be, a lot of operators will be available here, and we can install and we can configure that. But by default it don't have any load balancer because it's not like a production grade of cluster. That's the only thing we can say. Apart from that, most of stuffs will be there. So pods, so everything should be in running state, should not be in uh, error or class loop back off, we can see. And what else we want to consider? Nodes. So nodes, everything should be in ready state. See, none of them are in not ready state. Fine. Then now we can explore in terminal also. Most of time we will explore in terminal because storage kind of things at all we can't sense in the dashboard. and this metric for every single pod we can see the dashboard. So we will go for that. So namespaces, everything is there. So what we're gonna do now, we're gonna explore in terminal right now. Okay, see, two pods are creating. Okay, it's went fine. Okay, so I have a few set of commands. First, okay, first we want to know version of the client and the server CLI versions. Okay, we'll get the OC version. Okay, so client version is 4.18. That means right now I'm using this OC CLI is a 4.18, and customize version 5.4, and server version, that means this cluster version you can see 4.18.2. So that is what we are seeing here. Sometimes it will be a main question in the interview also. And for this version, Kubernetes version is 1.31. That means every quarterly Kubernetes will develop and they will release a latest version. What OpenShift will do, they will take a version code and they will upgrade their cluster underline Kubernetes, and they will release with the patches as a upgrade. So at the time we will go for the another version, like 4.14 is the right now in the standard unstable version. So that for that Kubernetes version will be 1.27. So right now CRC they're giving us a stable version 4.18 and Kubernetes version is 1.31. That means they are upgraded. I think Kubernetes version is right now in the market I seen 1.33 nearly, I think. So this is the version for this OpenShift cluster. And OC API info, sorry, get info, I think. Cluster info, yes. Okay, control plane, yeah. So this is the API. We similar kind of API will be available in the production cluster. We can get it, and we can use that to log in also. And for sometimes we want to troubleshoot it, like cluster won't reachable. So this is the API server in control plane. The API server will keep on running. So sometimes any issue in the sense resource or some kind of latency drop, uh, if it's facing any issue, then we can't reach the API. So at the time we want to check the API whether it's reachable or not using the curl or testing which it's some other networking stuffs. Okay, we want to check that. Okay, now we will go for the cluster operators. Okay, operators which are third party, which are provided by some another community, those are taken and developed by the OpenShift. They integrated their um, um, code and everything, and they will release in the OpenShift hub, operator hub. So for example, you can see the GitOps, the Market Jenkins, they developed and they released as a Red Hat GitOps, like that, OpenShift, Red Hat GitOps, such kind of things. Okay, now we can go for OC get cluster operators. It is a main like a major we want to notice availability, everything should be true, and progressing should not be true, everything should be in false. That means it's running in background means it will be in true. If it's true, some backend dependency will be affected, and any jobs are happening, any applications are running, it will affect them. So at the time we want to be noticed, and we should not run a lot of jobs in the cluster at that time. It's while it's being in the progress. Then majorly we want to check these conditions on a regular basis, and OLM will be there. It will manage and update the cluster operator automatically, or manually we can also do that. Then on while the upgrade, we want to ensure everything is in the stable condition. So that's a crucial thing we want to notice here. Then so in the cluster operator, we want to um, like inspect like four components which are in Kubernetes. The four components will be in the kube system. In OpenShift, those components will run in the separate namespace or project. So for example, control OpenShift API. So we can remove the OpenShift. So we can see the API server, control manager, and scheduler will be there. Scheduler, kube control manager, kube API. See, and the one thing, API server is there. etcd will be there. I couldn't see the etcd. So here we can see the etcd. Yeah, etcd is there, and DNS operator also there. Okay, these are the main components you want to ensure. So let me explore one by one. So in API operator, server is running, API server is running. Okay, then we can like how much resource it's consuming, we want to know means. So just type top. Okay, the pod is consuming nearly 6 m CPU millicore and 135 MB, right? So similar for all the components, we can check one by one, or rather we want to ensure the cluster resource how much it's going on the dashboard itself. Here we can see this is going fine, so we don't want to bother. So we can ensure like this. Right, and especially sometimes it's a simple one pod it's running, so 5 out of 5 is running. That means a 5 container inside the etcd it's running. So we want to know how much resources are consumed by um, which container. In the aspects we want to describe them everything. So we can run the simple command. So simple, so we can add the adm top. Okay, adm top pods hyphen. You can remove the labels, right? See, it's a only one, sorry, No, it will be multiple. So containers, we want to give the, want to pass the parameters, right? So now we're getting a multiple containers which are running inside the namespace inside the pod, the etcd namespace, right? Sorry. uh, so each containers are consuming a different cpu memory, so everything we can calculate that. This the etcd ctl, this is a command line uh, pod, I think. So if we want to run some command, we want to use this. So it's consuming very less. Okay. And so in monitoring we can see a different what kinds are available, route. And okay, now so we can see the all the components running inside the OpenShift monitoring namespace. Okay, including kinds like a pod or deployment services. See, services, name it giving a kind also as well. Deployments, replica sets, stateful set. If we are not include the so kind, so what will happen, we will see. So both are showing the similar aspects. Okay, then we go for logs for example, if we are running we want to check a pod or debug a pod, so we can run like this, like monitoring. There is an pod in the monitoring, OpenShift monitoring alert manager. So we want to use the OC logs alert manager and the pod name hyphen namespace, right? OC log. So this is the command OC logs, right? Right. Under this, we can guess if any errors are there, what currently it's running inside it. We can get some idea, right? Uh, okay. Next, logs, then events. So cluster operator, and we checking the components and resource consumption, logs, events, and we debug the node or pod. So we go for that. So now we going for the events, right? So for example, events in the which namespace cube controller manager. Okay, for example, OC get project, OC get project. See, in this namespaces, we will take a we want to get some events from the particular namespace. Okay, we will go like this. It will be a confusion. Once which namespace we want, we will take a random namespace, infra, right? Take this and paste it here. So there is no resource under this namespace, right? We will take mission API, definitely. Hope it will have. Yeah. So see, a lot of events, a lot of things are running inside that, right? Yeah. Okay, events. Then we're going for a node level of health check and troubleshooting, right? So we can explore like this. OC ADM top node. So in this CRC only one node is there, right? Okay, getting 50% CPU and okay, right? In multiple nodes we can see, and so we can describe the node and we can check the status of the node. For much details, we can get it the event C, update node allocation limit across pod, starting kubelet. So again and again, it's pushing the kubelet to start. Why? The node have sufficient PID 80 days ago. Okay, it should be a false, right? CPU, here see, here we can see the resource allocation and how many pods are running, what namespace, so everything we can get the idea. Say underline OS and all the details we can get it. Huge pages 0, not enabled, right? False. So here we want to consider condition, everything should be in the false except ready state, right? Annotation, right? Okay, then we want to consider multiple services inside the node, that those are keep the node on up, and those components are the main communicating with the API or pushing the image, pulling the image, and handling the underlying services inside the node. Those are very important in between. This Creo and kubelet are the main components. We want to consider them as a main. So we want to check whether the services are up and running or not. So I want to check them, right? So for that we can get the node logs. How we can get? OC, ADM, node logs, the node name, and Creo. So we can use like this. Unit for like which unit, kubelet or Creo, which one? Okay, right? We're getting a lot of events, so we will filter with a tail, right? Tail. How many? 5. We'll give 5. 1 2 3 4 5. Yeah. So we're getting a last 5 events, right? Okay. So now kubelet. Okay, we went for Creo. Now kubelet. We're checking kubelet. That also. So those logs, see some error are there. Clean up. Alright. Okay. Now we're gonna log in into the node. If we consider, or we came to know a node having an issue right now, and now we're gonna get no, right? The CRC. Okay, what we're gonna do? Debug bug the node slash CRC, right? Yeah. So once we logged in, you should run the ch root host, right? Now we can check the what are the present things in the node. So we want to check the services. Mainly we want to check the services. So I have the script to check the kubelet and Creo active or not. So I'm pasting the script and it will show kubelet active, Creo also active. So manually how we will check kubectl status of the kubelet? We will paste this. So kubelet is active right now, right? Yeah, everything is fine. So going to check the Creo as well, right? So now node also, like Creo also in active status. So these are the basic things. If you suspect the node is not ready, you want to SSH into the node and you want to debug. We want to check this main 2 components. These are active, then the node will be like mostly in the healthy condition. You want to check the further like underlying tuned OCP service or some another kind of parameters. So these are active and these are reporting to the API server. It's a meaning. So these are node level troubleshooting. So if you want to troubleshoot a pod, like it's in a production or something, so what you want to do, you want to debug the pod. Like we're gonna create a pod like OC run pod name. Okay, I will give a help. It will be sometimes it will be push to crash loop backup if we create something. So they will give a good example. So I like this really in this Linux or whatever. I will give a example also. See, we will run the nginx. Look at here, a pod will run. So it's creating a pod. It will be in healthy, I hope. Right? It's creating. Still, it's creating. Yeah, it's running, I hope. Right? So now what we're gonna do? So this is a production application pod. We consider it like that, and we can't take a SSH. Like we can't enter into the pod. It's right now in an error or something. So we want to know what's the condition or what's the exact reason we want to know little. So we can try to debug the pod. So we can clone this pod, the exact same configuration we can create. So with the command of OC debug, so it will clone the same pod configurations, everything, and it will create the pod. See, starting another container, right? Debug container. See, terminating pending state. We'll release them, and we are in the default project, so we can see here workloads. See, nginx we have created. Now debug pod we have ran to troubleshoot that, right? No routes, no services. See, we can see the details of the pod. Overview, 2 pods. First pod is running, yeah, see. So this is the exact pod, and now we're seeing a debug pod. Right now we have created. So what it will do, we can take SSH of it inside. Once we exit, and this pod also go off. So it automatically will be terminated, right? So ls. So okay, now I'm gonna check up time. Not sure. Date. Which command? Oh yeah, it's working. W. No. Right. Okay, I'm exiting right now. See, that pod have been terminated. Debug pod have automatically terminated. Remove debug pod. Yeah, right. So that's it, guys. In this video, it's please command like what exactly you have understand or anything else. Thank you.